Okay, so we're going to basically begin the section on 10.1, and we're going to highlight and talk about the rules of exponents. And here, mainly, I have a shot of all the rules of exponents that we will discuss. The first one here is, let me see if I can do that. The first one here is talking about the product rule. So we're going to begin looking at the product rule as well. So let's begin with looking at some problems reflecting the product rule. Let me go to my board. All right, so here let's talk about the product rule. And mainly, if I can move this up. Having some technical issues there. All right, so let's, I don't know why my screen keep moving. Okay. All right, so with the product rule, here's what we will pay attention to. So mainly with x to the a power times x to the b power, what will we do is we will simply add the exponents. So that's what we're going to demonstrate here, is add the exponents. Why is this thing shifting? Okay. So let's look at a few models to demonstrate that.
पेपर तुम क्लाउड हुआ था मुझे ये डाउनलोड किया था मैंने कहाँ है तुमने Zoom डाउनलोड किया था ना उस दिन
All right, here we go. Oh, I'm sorry, Mahib, could you mute your phone? I'm recording this lesson. Could you mute your phone for me while I go over the lesson? And anyone else, please mute your phone. I'm recording this lesson for everyone else that hadn't attended. Thank you. Okay. So here with the product rule, what I would like to do is show how we will apply by adding the exponents. Now, the main thing that we will need to be attentive to is that we will understand that if you note that they have the same base, x and x. So as long as we have the same base, we're able to add the exponents. So here at model A, x to the second power times x to the fourth. Notice I have the same base. I can add the exponents. Then my final answer is x to the 6. All right, final answer there. So that's pretty much as simple as it is with applying the product rule, is adding the exponents. B model, a times b to the 6. However, we need to note that the bases are different. So therefore, we cannot add exponents. So final answer here is simply ab to the 6. C model, 4 to the second times 4. Well, once again here, I can see that I have imaginary number exponent-wise with 4. What is the imaginary number there? It is 1. So what will I simply do is add 2 plus 1. That will simply give me 4 to the third power. And we can use calculators, of course. So multiplying 4 times 4 times 4, where 4 times 4 is 16. 16 times 4 is 64. that final answer is 64 for 4 to the third power. So in some cases, you will simplify to basically state the number answer. Likewise on D here with 2 to the third power times 2 to the second. Once again, same process. We have the same basis of 2. I will simply add the exponents 3 plus 2. That will come out as 2 to the fifth power. And that will also simplify. 2 to the fifth power will become 32. Again, simply place that in the calculator and it will compute that for you. All right, E model, negative 2 to the fourth power times negative 2. So what will I observe here? Once again, I will add the exponents. 4 plus, there's the imaginary number. What is it? 1. So I will add the exponent. Negative 2 to the fourth plus 1, that will become negative 2 to the fifth power. And there, once again, I will multiply negative 2 out to the fifth power. And there again, this time it'll be just a negative 32. Final answer. All right, so let's look at a few more three more problems replacing the product rule. And here there'll be a little bit more advanced. So, and once again, I am recording this, so this will be available to review again if needed. I will upload it and share it with the class. So we will have this available. 2 to the y to the second power times 3y to the ninth. All right, so once again, multiplying this out, we can identify that here with these two monomials is that we will multiply the numbers. What are my numbers? 2 times 3. Then I will assemble my variables. What are those? Y to the second times y to the ninth. So once I assemble that, I realize that 2 times 3 will give me 6. Applying the product rule, y to the second times y to the ninth, I will add my exponents, and that will give me y to 2 plus 9, 11. Final answer, 6y to the 11th. Model H, negative 3x cubed times negative 4x cubed. Once again, we will demonstrate the same process. So what will we apply number-wise? The integers negative 3 times negative 4. And here I will show the variables of x cubed times x cubed. So what do I realize here? That here negative 3 times negative 3, two negatives make a positive. That result will be a positive 12. Once again, applying the product rule, x to the third times x to the third, I will add the exponents, and that will simply allow me to get x to the 6th. So final answer here is negative 12, positive 12, x to the 6th, because two negatives make a positive. My equal sign was throwing me off. All right. And last one for the product rule. Negative 6ab to the second times 8ab cubed. So once again, we will assemble as following. So here I will deal with my integers, which are negative 6 times 8. I will now deal with variables. In this particular model, we have two sets to deal with. We have a times a, and we also have b to the second times b to the third. So once you put everything and congregate it together and assemble it, it kind of makes it easier to process how to multiply applying the product rule. So negative 6 times 8 will give me a negative 48. A times A, imaginary once again, 1, 1, add that up. 1 plus 1 will give me A squared. And B to the second times B to the third, that will become B to the fifth. So final answer here is negative 48 A squared B to the fifth. And that is how we apply the product rule, okay? All right, so the next rule we will look at, just a moment, is now we're gonna look at the zero exponent rule, okay? So here at the zero exponent rule, notice what it says, that a to the 0 power is equal to 1. So let's evaluate that, and let's look at a few models that will assist us with that, okay? All right, so once again, what happened? Oh my, what in the world happened here? Oh. All right, so let's apply the 0 power rule. All right, so once again, as it highlighted, it stated that basically anything, it said a to the 0 is equal to 1. So anything to the 0 power is equal to 1. So given that 10 to the 0 power, again, that's anything to the 0 power, whatever the base is, if it's raised to the 0 power, that answer is 1. So 10 to the 0 power is 1. Here at B model, we have x to the 0 power times x cubed. So once again, here first, x to the 0 power, that will be 1. So what I actually have now is 1 times x to the third power. And so what that result will be, x to the third power. Final answer. And notice here at C model, we do see that we have negative 6 raised to the 0 power. Once again, any base raised to the 0 power, that answer is 1. All right? So that is just how simple we apply the 0 power rule. All right? So next up is applying the quotient rule. And so here, the quotient rule basically tells us that we have, I don't think you guys can see that. Is that the quotient rule, I would just write it out here. It basically says that x to the a over x to the b. And what will happen in the quotient rule is that we will minus our exponents given the larger exponent, position of the larger exponent. So let's look at a few models and let's practice applying the quotient rule. All right, so here are our A, B, C, D, E models, our 5 models we're going to look at involving the quotient rule. And mainly, once again, applying the quotient rule, I think that is simple enough with that. All right. So here with the quotient rule, we can identify here that x to the 6 over x. All right. So what we first identify is that the exponents, which is x to the 6, and that is where the subtraction will occur. And this x is considered imaginary exponent of 1. So there I will simply show my subtraction, x to the 6 minus 1, and that will become simply x to the 5th power. Final answer. Just that simple. Same process with B model. Y to the 8th over y to the 2nd. What we'll identify here is that 8 is my larger exponent, so that's where the subtraction will occur. And there I will show 8 minus 2, and that result will give me y to the 6th. Final answer. Yes, just that simple. All right. And the same process with C, which we can identify that both have the exponent 2. So we already know that 2 minus 2 will give me x to the 0 power. And once again, anything to the 0 power, we know that is equal to 1. Final answer, 1. And however, with D and E, with the monomials, we will simply look at 15x to the 10th, divide 3x cubed. Here, with applying the quotient rule, we realize that we will do a separation and divide 15 and 3. And then we will deal with the exponents x to the 10th over x to the 3rd. So right away, 3 and the 15, that will become 5. And the subtraction will occur here at 10 with being the higher exponent. And then we will do 10 minus 3, and that result will be x to the 7th. Final answer, 5x to the 7th. And E model, 20x to the 10th, y to the 6th, over 2x squared, y to the 3rd. So how will that breakdown look? We will have 20 over 2, x over x to the 10th over x to the 2nd, y to the 6th over y to the 3rd. Begin the process and divide 2 into 20, that's 10. Here, subtract the 10 minus 2, that will give me x to the 8th. Subtract y to the 6 minus 3, that will give me y 3rd. Final answer, 10x to the 8th, y cubed. And that's pretty how we apply the quotient rule. So with the product rule, the 0 power rule, and the quotient rule, hopefully those are not too bad. And let's continue the process. And I technically only have 2 more rules to cover, and we will call it a day. Hold on just a minute, guys. Okay, sorry for the delay. All right, so quickly, let's look at the negative exponent. All right, so here with the negative exponent, what happens when we have a negative exponent is we want to always show it in the positive state. So by doing that is where we will apply the reciprocal. So the reciprocal basically means to flip and make it into a fraction. So here technically, to bring it into the positive state, we will basically put the number in the denominator. All right, so let's look at some models again to reflect how do we take the negative exponent and bring it into a positive exponent. So let's look at a couple of models of that, and I think you won't have a problem there as well. And we will continue the process. All right, so now let's look at these three models. A model, 5 to the negative 1, B model, x to the negative third, and C model, where we will multiply x to the negative 9 times x to the 7th. So at A model, 5 to the negative 1, how do I simply bring this to a positive state? Well, technically, all I would need to do is do the reciprocal. So what will I do? I will basically, we see 5 is up top as a numerator. I would simply bring it to the denominator, and that would be my positive state, 1 over 5. So that's all we're doing when we're dealing with negative exponents, is simply flipping that exponent. B model, x to the negative third. How do I bring that to a positive state? Same process. Even though it's a variable, we will still show the flip. So I will show 1 over x to the third. Final answer. And C model, applying the product rule, what will I observe here? Because we have x to the negative 9 times x to the 7th, we will add those exponents. Negative 9 plus 7, result will be x to the negative 2. Once again, what do I observe? How do I bring that to the positive state? I will flip that, and the positive exponent will become x to the 1 over x to the second power. Final answer. All right, so now let's look at a few advanced regarding the negative, but I don't think you will have a problem with these as well. So and this will be reflecting the power, applying the product rule, and then the last thing we need to talk about is applying the power rule, and we will call it a day. All right, so let's look here at model D. All right, 2 to the negative 5th times 2 to the 8th power. So what do we conclude here with this negative exponent? Well, first things first, we must apply the power rule. So we realize with the same base, we're going to take negative 5 plus 8. And so what do I realize I will get out of that? 2 to the third power, which 2 times 2 times 2, which gives me the value of 8. Final answer. So here with that negative exponent, we just simply applied the product rule by putting it all together. Here, given x to the 6 over x to the negative 1, that exponent kind of look a little odd, but it is a negative 1. So what will occur here again is that we realize that we will have to apply the quotient rule and show x to the 6 minus negative 1, because that's a negative 1. So what do I realize there when I subtract? That I will get x to negatives make a positive, that I will simply add that. And that will turn into be x to the 7th. Final answer. So here's where we have to reason and apply the appropriate rule to simplify the exponents. Same process with 10 to the negative 5th times 10 to the negative negative 2 square. Now, first things first, both exponents are negative. So to bring it to a positive state, 10 to the negative 2 will become positive when I basically bring it to the numerator. 10 to the negative fifth will become positive when I bring it to the denominator. Okay. So now we have it in the positive state. So what I need to do now is I need to subtract, okay? So I will subtract at the larger one, all right? So there, what will happen is that my larger exponent is at 5, so it will occur in the denominator in this example. So once I simply show 5 minus 2 and get 10 to the third power, now I know that I have a fractional part. So what will I place in my numerator would be simply a 1. And so 10 to the third power will be expressed as 1,000. So my final answer could be 1 over 10 to the third power or 1 over 1,000, final answer. As we continue G model, here what do I show? X to the 6 over X squared, Y to the third over Y to the 5th. I will simplify that by simply subtracting 6 minus 2, applying the quotient rule at the larger exponent. That equals X to the 4th in the numerator. Then I observe Y cubed, Y is my Y to the 5th. The larger exponent is in the denominator. Subtraction will occur in the denominator. 5 minus 3 will become 2, and that will give me Y squared. Final answer here is X to the 4th over Y squared. All right, and last model. All right, let's look at this model. All right, so here we show, let's do the breakdown of what we have. And here we show that we have 15 over 3, x to the 10th over x to the 15th. And we also have x squared. All right. So first things first is we know to divide 3 and the 15 out, and that will give me 5. Now, right away with x to the 10th times x squared, I will apply the product rule. Well, I will add the exponents. 10 plus 2 will give me x to the 12th over x to the 15th. So what do I observe here is that I have 5 that's in my numerator, and the 15 will mean the subtraction will occur in the denominator because it's the larger exponent. So 15 minus 12 will give me 3. Final answer here is 5 over x to the third power. Final answer. This concludes section 10.1. And I hope that this was helpful and enlightening to you guys. And we will cover 10.2, 10.3 on our next meet day. Give me just a moment. Let me stop the recording class, and then we can go with further discussion.